we move on to chapter 12. So your next exam is going to cover the sections from chapter 10, and then we cover 3 more sections here in chapter 12. The two don't have anything to do with one another, but they're both short sections or short chapters, and so I find it fits well for one exam. We'll come back and do chapter 11 later. Anyway, chapter 12, it's called Sequences and Series. Very different from anything else we've done in the course so far. There's nothing here, nothing to do with functions. There's no graphing. There's really not even solving, like in the sense of solving exponentials and logs or quadratics. So what is this all about? 12.1 is going to be our intro. And then in 12.2 and 12.3, we look at some specific sequences and their series. So let's go ahead and begin just by defining what a sequence is. And we'll talk about that for a while, then we'll define what a series is. Okay, so a sequence is a list of numbers in a specific order. So if you've got a list of numbers, that's a sequence. If you change, maybe you swap 2 of the numbers, then we'd say that's a new sequence. Not that that's really going to be a big point of contention for our discussion, but that's the idea. The order does matter. So let's look at an example. And I'm just going to give you everything I have to say here, just all at once. Okay. Maybe we focus, that's kind of a lot. Maybe we focus just on just that first part there, and I'll cover that up too. Okay, so our sequence 2, 4, 6, 8, 10. I just picked something real simple. A list of numbers in a specific order. And just to give some key terms for what's happening here. So the 2, ignore this for a moment. The 2, we call that the first term. And here's the notation that we use. We use a lowercase a sub 1 for the first term. Why the letter A? My best guess is because it's the first letter of the alphabet, and that sub 1 indicates that it's term number 1. The first term equals 2. And then we could go on. The second term that we'll call a sub 2 is the 4. And the third term, a sub 3 equals 6. And, of course, I didn't write it, but that's the fourth term, a sub 4. And the fifth term, a sub 5, equal to 8 and 10. Of course, the sequence goes on forever. Any sequence is always infinitely long. So typically you see this dot, dot, dot to indicate that it goes on in that same pattern forever. Okay. Now what we'd like to have is a formula for how to generate each value according to which term it is. So we call that the general term. So in this sequence, if we were in class, I'd probably ask you guys, hey, what's the formula for the term? So we call it a sub n, all right? Sometimes you hear it called the nth term, or the general term. A sub n, so depending on what number we see here, right? That's the 1, the 2, the 3, the 4, the 5. How do we come up with a formula for that takes that number to generate these numbers? You think, oh, well, term number 1 is 2. Term number 2 is 4. 3 is 6. 4 is 8. What's happening? I'm multiplying them by 2, right? Times 2, times 2, times 2. So if I take that value and I multiply it by 2, that's how I'm going to generate these numbers for this sequence, right? So a sub 1 would equal 2 times 1, that sort of thing. Okay. Let's check out several different sequences. We're going to be asked to find the first 3 terms and the 50th term. So here we're really just getting used to this idea of how the general term works, a sub n, and how it connects to the term values. So the first three terms are the first term, the second term, the third term, and then we'll look at the 50th term as well. Let's start with a sub n equals 3n plus 5. Okay, so to find the first term, a1, we're going to write a1, and we're just going to put a 1 there where the n is. So a sub 1, oh, it looks like I'm showing you a3 as well. So let's ignore that for the moment. A sub 1 equals 3 times 1 plus 5, and if we simplify, right, we get 3 plus 5. The first term here is 8. Okay, I'm just going to go ahead and show you all the work here for this first example, but we'll talk through them one at a time. The second term, a sub 2, well, that's 3 times 2 plus 5, which turns out to be 6 plus 5 is 11. The third term, a3, 3 times 3 plus 5, which is 9 plus 5, 14. And they say they also want the 50th term. Okay, a50, well, that's 3 times 50 plus 5. That turns out to be 155. There's the 50th term. And you notice these sequences, they really do work a lot like functions. They're not functions, but, you know, it behaves in the same way. Whatever number you see, that's what you plug in, just like f of x, right? Whatever value x takes, that's what you replace x with. Exactly the same idea. Okay, let's move on to another example. Just one more of these. How about this? The general term a sub n equals negative 1 raised to the n divided by n to the third. So n appears twice. Well, what does that mean? You know, if you tell me which term number you're looking for, well, I have to plug that value into both spots. So still here, we'll find the first three terms and the 50th term. Let me just show you everything, and then we'll look at them one at a time. So a1, okay, so I put a 1 in for the n there and the n there. Negative 1 to the first over 1 to the third. Well, that's just going to be negative 1 divided by 1, negative 1. How about the second term? Negative 1 to the second power divided by 2 to the third. Well, negative 1 squared is positive 1, right? And 2 to the third is 8. Okay, the third term, a3, well, the 3, negative 1 to the third comes back to negative, and it's over 27. And finally, the 50th term, negative 1 to the 50, well, that's an even power, so it's going to come out to positive 1. And 50 to the third is this, 125,000. So there you go. Okay. Sometimes you're going to see this thing called the factorial. It's kind of an interesting operation. If you see an exclamation point next to n, then we read that as n factorial, or maybe, just to give you an example, let me cover this up before I explain. You know, we can obviously put a number there. This would be 5 factorial. If you look on your scientific calculator, you might well find that exclamation point as one of your buttons. It might be under a mode somewhere, like math mode, if you've got a TI, or it might just be right there that you can see on one of the buttons. Okay, so what does that even mean, factorial? Okay, so the idea of the factorial is you take that number and you multiply down until you get to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. You start with the number and then count down the integers until you get to 1, multiplying every time. Kind of a really weird thing, but it turns out it's actually really useful in certain types of applications. Okay, so, well, you might want to grab a calculator here. What is 5 times 4 times 3 times 2 times 1 if we just multiply it out that way? Turns out it's 120. Or maybe you just have the factorial button in your calculator and you don't show this step, you just punch that right in and get 120. That works for me too. Okay. So let's take a look at part C. We do have one last example. Ignore this for a moment. Here, the nth term, the general term, is n factorial over n plus 1. And same instructions, we want to find the first 3 terms and the 50th term. Okay, well, let's go for it. I'll show you, well, let's just look at everything and then we'll just talk about things one at a time. So the first term, a1, well, of course, that's 1 factorial over 1 plus 1. 1 factorial is simply 1, right? I mean, the way it's defined, if you start with 1, there's nothing more to do. So 1 factorial is 1, and of course it's over 2. So 1/2 is a1. a2, 2 factorial over 2 plus 1. While 2 factorial, start with 2. 2 times 1. 2 factorial is actually just 2. And then the denominator, 2 plus 1 is 3. Okay. The third term, a3, well, we've got 3 factorial over 3 plus 1. 3 factorial now, 3 times 2 times 1. So that gives you 6. And it's over 3 plus 1 is 4. And let's go ahead and reduce that, 3 over 2. Okay. So there's the first 3 terms, and then we also want the 50th term. So that'd be 50 factorial over 50 plus 1, and you can see my note here. If you've got a calculator with the factorial button, I invite you to go ahead and tell it to compute 50 factorial. It's going to be far more numbers, far more digits that can even fit on the screen. So it's going to give you some funky notation. I wanted to go ahead and do that, but that number is just way, I have no idea what that number even is. It's massive. 50 times 49 times 48 times 40, it's this huge number. So I'm just going to leave it like that, 50 factorial over 51 for the final answer. And I thought it was neat to bring up something like 50 factorial in the lecture. You won't be asked a test question on something like this. The factorials that you might be given will be reasonable ones like 5 or 3 or, you know, even like 8 factorial isn't so bad. Once you get up to even like 12 or 13, those numbers start to get really big, and definitely 50. Okay, let's stop the first video here. I think we've introduced sequences really well. Coming up in the next video, we talk about series. See you there.